Hey there, everyone. Have you ever noticed how things like your phone or even your car engine can get warmer when they're working? That's energy being transferred. And guess what? Understanding these energy changes is all about thermodynamic processes. In thermodynamics, a process is simply the way a system changes from one state to another, like how a gas expands or how heat flows in and out of a system. But here's the twist. These processes can happen in many ways and they all follow some cool physical laws. There are a few key types we need to know about, such as isothermal, adiabatic, isobaric, and isochoric processes. Let's take a dive into these different processes and see what makes each one unique. Let's kick things off with the isothermal process. Imagine a balloon filled with gas. If you heat it up, the gas inside wants to expand. But in an isothermal process, the temperature stays the same the entire time. Sounds crazy, right? But the temperature doesn't change because any heat added to the system is used to do work, not to change the temperature. This means the relationship between pressure and volume is constant and follows Boyle's law. PV is constant. As pressure decreases, volume increases, keeping the temperature constant. This is why your refrigerator works. It uses isothermal processes to transfer heat without changing temperature drastically inside the fridge. Now let's move on to an adiabatic process. Think of a fast-moving piston or a pressurized gas being released. In an adiabatic process, there's no heat exchange with the surroundings, meaning no heat is added or removed. This is why when you quickly compress or expand a gas, its temperature changes. The equation that describes this process is where gamma is the adiabatic index, which is specific to the gas. Since there's no heat exchange, all the work done causes changes in the internal energy, which shows up as a temperature change. Imagine a bike pump. You'll notice the pump gets warmer as you compress the air. Now, let's dive into the other two processes, isobaric and isochoric. In an isobaric process, the pressure stays constant. Think of a gas inside a cylinder with a movable piston. As the gas heats up, it expands, doing work against the piston, but the pressure remains the same because the container is able to adjust. The work done in this process is W equals P times delta V. In an isochoric process, the volume stays constant. No work is done because the volume doesn't change, but if heat is added, it causes the pressure to increase. This is what happens inside a pressure cooker. The volume of the container doesn't change, but the pressure rises as the temperature increases. Let's apply these concepts with a real-world example. Imagine a gas in a piston at a constant pressure of 2 times 10 to the power of 5 pascals, and its volume increases from 1 cubic meter to 3 cubic meters. How much work is done by the gas during this isobaric expansion? We'll use the work formula for an isobaric process, W equals P times delta V. Now, substitute the values. W equals 2 times 10 to the power of 5 times the difference between 3 and 1, which is 2. So, the work done is W equals 4 times 10 to the power of 5 joules. That's a lot of work done, right? So, this shows how heat energy goes into expanding the gas and doing work, even though the pressure is constant. To sum it all up, thermodynamic processes explain how systems change over time, with different rules for each type. In isothermal processes, the temperature stays constant. In adiabatic processes, no heat is exchanged, and in isobaric and isochoric processes, either pressure or volume stays constant, changing the system in different ways. These processes govern everything from engines to refrigerators, helping us understand how energy flows in systems. I hope you now have a clearer understanding of how these processes work. Whether you're studying for exams or just curious about the physics behind everyday systems, these concepts are key. I'll see you next time with more exciting physics.